Okay, the name of our next problem is vibrating mass on a string. We can summarize this problem, the system, as this. We have a string and a mass m and another string connected to a fixed point. These strings are, well, there is tension on both strings, and the magnitude of the tension is T. And there's no gravity, so it's in free space. So if it is in free space, if we do not touch the system, it will stay still. However, when we pull the object slightly up and release it due to the tension on the strings, it's going to move to its original position and will continue to move, so it's going to oscillate. The question is, what is the relation between the frequency, tension, mass, everything? In order to solve this problem, we need one more information, which is the length of the string. It's a symmetric string, so the length is L. In order to find the oscillation of the system, we need to write the equation of motion. In order to do so, we need the free body diagram for this system. So let's assume that we pull the mass slightly, we disturb the system slightly. Here the keyword is slight. If you disturb the system large enough, then the problem is going to be very difficult to solve. But a small disturbance, definition of small, I will define the definition of small momentarily, like that, disturb the system and release it, it's going to oscillate. I'm going to draw the free body diagram at that point, theta. So free body diagram, there are strings connected to the object, no gravity, m. If the tension on the string is T, when it is released, when I disturb the system slightly, the tension is going to be slightly different. Let's call this T prime. T prime. If it is slightly different, T prime can be approximated to the first order as T. So that is also T prime, approximately equal to T. And since there is tension, the force applied on this mass is going to be in that direction. So these are the two forces acting on the object. As we expect, the object will accelerate due to these forces downwards. So this is the direction of the acceleration, A. So we are done with the free body diagram. We of course need to give the quantities here, the angle is theta. And that's all about the free body diagram. So let's write the equation of motion according to this free body diagram. We need to define the coordinate system. If this is x, this is y. The system is disturbed upwards. The acceleration is in the negative direction. And the y component for the equation of motion, the acceleration is to the negative direction. The total force in the along the y-axis is to the negative direction. So I just omit the negative signs on both sides of the equation. So the contribution of this force in the y direction is going to be the tension T prime multiplied by sine theta. Okay? So T prime multiplied by sine theta. But T prime is approximately equal to T, so I just omit the prime part, sine theta. This is the contribution coming from this tension. It's symmetrical system, so there's one more contribution coming from that side, which is identical to the left-hand side. So twice the force is equal to m times A. A is AY. And there is no component of the x component of the A. Acceleration is going to be to do let's do not omit the signs here. Okay. The contribution y component is going to be to the negative direction. Here we go. So acceleration is this is the y component of the acceleration. Whatever the y component, the sign of the y component of the acceleration is negative as expected. So everything is in order. So let's write this one more time. Sine theta is equal to m. The y component of the acceleration is y double dot. So the only quantity that needs to be inserted in this equation is sine theta. What is sine theta? So let me draw the triangle that we see here, like that. So this is theta, this is L, and oops, the other way around, sorry. Theta, y, L, this is L prime. L prime is square of L prime is equal to square of L plus y square. But here is the definition of slight disturbance. If y much smaller than L, then L prime is going to be approximately equal to L. Then sine theta is going to be equal to y divided by L prime, which is approximately equal to y divided by L. So when theta is small, sine theta is approximately equal to tangent theta, which is y divided by L. So let's plug in that information. Then negative sign, forgot it. Negative 2t, sine theta is y divided by L is equal to my double dot. Or let's solve this for the acceleration. Y double dot is going to be equal to negative 2t divided by ml y, and that is the usual equation that we encounter when we are dealing with oscillatory systems. And y double dot is equal to omega naught square y for convenience, where omega naught square is defined to be 2t divided by ml. So the solution of that such a system is this, as we have seen many times. Sine omega naught t is one of the solutions, but equally we have another solution, which is cosine omega naught t, and the linear combination of these two is also a solution. So that is that, with omega naught being equal to square root of twice the tension divided by ml. Note that this t is the tension on the string, not the period. Let's also try to figure out what is A, what is B for a special case. If we disturb the system by an amount of h, okay. Pull this by an amount of h, this is h, and release it slowly, find y of t. So which means that the initial value of the position, initial value of the y is equal to h. So y of 0 is equal to h. We release it slowly, so which means that it is starting its motion from rest. So initial velocity is 0. D of t is equal to 0. And we solve these for A and, we solve A and B for these initial conditions. Y of 0 is equal to h. This is 0. That is going to give me 1 is equal to b. So b is equal to h. And v of 0 is equal to 0 is yielding me a to be equal to 0. Take the derivative of that once. So that becomes cosine multiplied by omega naught. And this becomes sine. At t is equal to 0, this term disappears for the expression of the velocity. So the only thing which remains is a times omega naught, which is equal to 0. So a is equal to 0. Then for that case, r of t is simply h times cosine omega naught t. So that's the end of the question.